Hey guys, back for another issue of the Meteorology Lab channel. One of these days I'm going to get that out correctly. And kind of a quiet day here. We've seen just fair skies. We're under the influence of that ridge, and we've got a bit of a dry system heading this way. You've probably heard about the new GOES satellite, GOES-R, and it's actually GOES 16 now that it's almost operational. And there it is. There's that first image, and I guess we're coming up on the era of color satellite images. And for the past 40 years, we've been dealing with the black and white because of the limited bandwidth. And the NASA Aqua and Terra satellites, those have given us color images right there. But I guess this is the future here. As far as weather for today, things are pretty warm up in the Arctic area, including up in western Canada right here, and even the Hudson Bay area. So we don't have a whole lot of bitterly cold air on tap. We're going to have to wait for a pattern change up in this area for that to happen. And there we go. The U.S. pretty much split between west of the Rockies with very cold air, unusually cold air, and then we have warm air where we're at in the central U.S. So that's going to give us kind of a trough west, ridge east pattern. And there it is on the 500 millibar chart. You can see it all spelled out right there. Ridge to the west, and where's the polar front jet? Pretty much south of San Diego. We can trace that up through Oklahoma and out towards Georgia. And we've talked a bit about placing fronts, and you're going to find that very close to the jet stream between the trough and the downstream ridge. So that's the rule of thumb that you use. So we're going to look for this area, and the reason for this is because the entire reason this jet stream is here is because of a thermal gradient down at lower levels. So that means front to the south. Looks like a bit of ridging up in Canada, and then, as you might guess, the next system right here, and we can use that same principle to place a front like that. So pretty simple, isn't it? Temperatures today across Texas, very warm. We've had 80s where we're at, and even close to 90 there at Junction, northwest of San Antonio, and 91 at Eagle Pass. But you can see much colder weather, and remember, these are high temperatures. So 41 in Albuquerque there, 54 at El Paso. This is all below normal. So that probably demarcates where the surface front is. Then we can extend that north a bit, and pretty good contrast there in Missouri. Between 70s and Springfield and 40s to the north. So this is another way you can use all the data to really prepare for the surface analysis. Okay. Wow, I was just seeing temperatures below freezing up at Tonopah, 27 here. Again, this is not bitterly cold, but that is a bit on the cool side here. Let's check out the soundings. We like to do this even during fair weather, because if you look at the stuff just during bad weather, then you don't have kind of a baseline of what's normal. So the Fort Worth sounding this evening looking like this. Remember, increasing temperature on the x-axis and increasing height on the y-axis. So this is telling us very warm near the surface and fairly cold aloft. Tropopause up pretty high and fairly dry air. Remember, this is the moist line. The further this is to the left, the lower the moisture at that level. And some of you may not be too clear on that. The distance this line is to the left, the further it is to the left, that's kind of a function of mixing ratio, of dew point, of specific humidity, and then the distance between that line and the temperature line, that tells us relative humidity. Okay, so here we have some very good relative humidity, probably up near 70-80%, and that shows cirrus at that layer. So even though this is pretty far to the left, kind of in this zone here, the air is definitely dry, but it is humid. So that's the difference there when we're talking about moisture. Temperatures near the surface, or I'm sorry, dew points, pretty much in the low 50s, so this is not really going to support thunderstorms. And if we try to get a thunderstorm going, you can see we are pretty well capped. This is all capping here at about 700 millibars. And we'll take a look at a couple other soundings. Springfield, Missouri. Well, we know that that's going to be probably south of the front. And we can see it looks a lot like Fort Worth. It is Fort Worth. Let's try that again. Click. Okay, looks like that took. And it does look like Fort Worth here. So very, very similar pattern. But then if we take that up to the north, we'll go up to Lincoln, Illinois. Wow, it looks different now, doesn't it? Now this part looks a lot like the sounding we showed you earlier, but this part is different, and that's because the frontal inversion is there, and we've got the cold air mass sitting over Illinois. Very thin layer like that, about 2,000 feet thick. And you can also see the temperature, or I'm sorry, the wind direction change. A little bit of directional shear there, and we would get a little bit of cyclonic, a little bit of curvature there on the photograph. So if we were expecting severe weather there, moisture just to the south, and soundings looking like that to the south, that would be something that would support supercells. All right, give me a break here. I kind of rushed into the webcast. I'm going to take 10 seconds to take care of a few things. So just talk amongst yourselves. I'll be back in just a second. Okay, you've probably had a chance to look at that surface analysis, and let me take a look at the chat here. I see my levels are coming up into the red. Maybe I'm blasting your speakers. Let me turn the mic down just a little bit. Okay. All right, let's check out the chat here. Got Mark and Alexi in Central Texas. Andrew's here. Ron checking in from Southern California. Have Kevin McKinney here, and Alexi, I mentioned Alexi, Jason Boggs and Sarah Wood and up there in Indiana. Mike Bexley checking in, Michael Burrell. Mike Bexley says, downloaded wind grids, trying it out, and after 5 minutes haven't had much luck. Yeah, I know the feeling. It's a very formidable tool there. And I've mentioned maybe that would be a good thing to do a workshop on. But I'll show you how to get started real quick. Maybe this will help you out. I'm going to download just a very quick data set here so you can see how it works. I'm going to fire up wind grids. And it maximizes the window, so let me fix this. Okay. This is how we download data. First thing I like to do is clear out the data that's in there. So I go to delete regular grid files, and then I'm going to download the actual data. So I'm going to go to File, Download Grid Files, and then go to Regular Grid. Then I get this list, and what I like to pick is the NAM at NWSTG. And then some of these work and some of these don't. The 212 grid here, this works. So I'm going to grab the 212 40-kilometer grid at 12 hours from 18Z. That'll be the latest one we have. So I'm going to pick NMB 3182. So I'm going to grab that. It's going to download about 30 megabytes. If this disrupts the stream, please let me know. I want to know about that. But I don't think we're going to have problems. Okay, so here you can see the download coming in, and I'm on my crappy 6 megabit per second Windstream connection here. If we get the channel really going and get it kind of monetized, I'm probably going to get symmetric DSL, and we'll be able to do HD. But I'm going to need some donors and for that kind of thing to work. That line is about $200 a month, but we may get there someday. GR Level 2, $250. Yeah, it is an expensive program, unfortunately, but it is very nice. Okay, let's analyze this thing. This is the 6-hour NAM forecast, so it's valid for right now. You can see that very strong thermal gradient in New Mexico, separating the very warm air in the Texas Big Bend area from the air in Albuquerque. So it is very obvious where to put that front. And we're probably going to take that up into... In fact, yeah, we're definitely going to take that up into Missouri. Remember, we had 70 degrees there at Springfield, so there we go. Now you do see a few lines through here. This could be due to some cool air aloft, kind of biasing the thickness values. So again, this is where you have to look at all data. And the jet stream analysis can help. You're going to find that to the north of the front, and we did look at that earlier, but we saw the jet core right in this area this morning, right over Springfield, right over Atlanta. So when we analyze that surface map, yeah, that places it just north of the warm front, so everything is consistent here. Everything looks good. So that is the main warm front. And another thing we might want to look for is a dry line. So normally you're going to find it something like that because of the westerly wind component out ahead of the cold front. Okay, a couple other frontal systems, one on the East Coast. So there's that guy, and we're clear for a change on the West Coast. Nothing there, really. Maybe a bit of a weak cold front up here. But anyway, let's focus on the U.S. Let's check how our download is going from WindGrids. I think it is finished. Let me check and see if we had any glitches in the stream. Good, the download did not affect my stream upload. So once that is downloaded, we go to File and convert non-WAF's grip file, convert regular grip file. Then you're going to see this happen, and it's processing all of the frames, all the millibar levels here, all the dates, and all the times. So that'll take a few minutes, and then it will be ready to view. All right, 500 millibar analysis. Let's see what's going on in detail. This is heights and vorticity, and as I've showed you, this is how we like to find the short waves. But what we have here is more channeled lobes here. So this is, the upper level patterns are mostly defined by jet streaks right now. Try that again. Okay, so there's our jet stream. The jet streaks are in here, back in here, and we do pick up some advection lobes in here. These are short waves. So we're kind of finding the jet right like that, maybe a little bit north of Atlanta. So the jet has moved a little bit north from what it was yesterday. But we're still under the ridge here in the southern U.S. Okay, I think we're ready to head into the forecast, and we'll take a quick look at wind grids. We're going to open up that data file, go to New Process Data, and then pick out your file. And then it is pretty much ready to view. And you can see it confirmed we got all this good data. And then you'll be able to view most of these products here. And the one I always like to look at is the cross sections. We'll do that now. We'll go to Display Cross Section. And I'm going to set this up for going across the front from off the Gulf Coast to the Four Corners area. And you can see it's going to construct that here. And we are ready to view the cross section. Now I've got a custom written script here, so you're not going to have this. You're going to have some of this stuff, but not all of it. I've got this one here I've written for a time series analysis, and this lets me display the cross section here. So the front is like that. This is the Gulf Coast. This is Texas, Waco. No, this is about Midland. And then, yeah, actually this is Central Texas here. And then West Texas, and then the Four Corners area. So you can see that jet right there overlying the frontal boundary. And let's see, one thing I can show you is the momentum field real quick. This is kind of complicated, but it's pretty neat. Okay, so here, I don't know if you can make this out. It's very messy. Maybe I can stretch this out so you can get a better look. Let me regenerate that real quick. Yeah, you see here, this is the jet stream over New Mexico. We're just cutting right through the middle of it. And if you look at the red contours, you can see this tongue coming around the north side of the jet. So this is the stratosphere descending down to much lower elevations. And this is pretty neat because this is actual stratospheric air, and if you actually fly a research aircraft, say maybe 20, 30,000 feet above the ground, you will detect increased concentrations of ozone, believe it or not. And you can detect radioactivity from nuclear tests, if something like that's been going on. They did that a lot in the 60s, and you would see some of that air working down to the troposphere, and that can carry radioactive material down, and you can read some research papers about that. It's very interesting stuff. Okay, let's see here. Let me get back on track here, and we'll take a look at the forecast. Okay, let me take one more look at chat, see what people are talking about. Just talking about software programs. So if you're looking at the rebroadcast of this, the archive in my videos, you want to try to join the chat sometime because there's a lot of interesting discussions going on. So right now people are talking about software programs. And let's go ahead and go into the forecast here real quick. Okay, we know the front is pushing through Texas. There it is right there. Give me just a second here. Had to grab a drink of water here. All right, guys, let's move forward to tomorrow's forecast. So tomorrow, Wednesday evening's broadcast, we're going to have the front push through Tennessee and Mississippi and down to the Texas coast. And then a warm front, probably something like this, connecting up to an inclusion in the Michigan area. And there's that cold air advection coming in. Pretty similar to what we talked about over the past few days. No surprises here. Thursday's webcast, we see the remainder of the front push down south. Continues to cool down in Texas and much of the south. Friday's webcast, more boring conditions. A lot of cold air advection coming south. So very cold there for Sarah and Sue. Saturday continued pretty cold. A little bit of bear clinic development down along the coast. And the Great Basin High really building in here over Idaho, Nevada, and Utah. Sunday, we see a little bit of a warm-up on the plains. Air mass modification. Then next week on Tuesday, Alberta Clipper pushing southward here. So this is going to be a much drier, cooler pattern coming in for next week. And as I've showed you, the conditions up in the Arctic are a little bit on the warm side. So it doesn't look like we're going to have super cold air coming down south. It's just going to be a succession of mild air masses. So here comes a Canadian air mass, pretty well modified. A little bit of action here in the Pacific Northwest on Friday, the 3rd of February. And looks like kind of a north U.S. storm track setting up here. Then we get another outbreak of cool air, a little bit of a backdoor front into Texas, just ahead of this warm front. And then February 8th, another outbreak of cool air. So this is definitely a change, and I'm looking forward to it, actually. It has been just too warm here. We'll take a quick look at the Canadian forecast and see if it's got any surprises. There goes our frontal system midweek. There comes the cool down towards the weekend. Big Great Basin High building in, okay, just like the GFS. And I think it's going a little bit harder with this chunk of cold air early next week. And that's affecting the Midwest and maybe parts of Oklahoma, parts of Arkansas. And you remember back 3 or 4 days ago, we were comparing the European model and the Canadian model in GFS, and we were seeing how far east and west the edge of this air mass was. So Canadian kind of pushing the edge right here. The GFS yeah, the GFS has a different forecast here. It doesn't bring that cold air mass down until the 1st or 2nd. Okay, so we do have a difference here. Let's see when that happens. Cold northwesterly flow. Hang on, this is a little bit off center. There we go. Sorry about that, guys. Cold northwesterly flow on the 27th. The core of it on the Canadian model coming through the Great Lakes on the 27th. And no Alberta Clipper until the 1st and 2nd. Okay. Then the GFS had a very cold northwesterly flow. Okay, here's the difference. It keeps the bulk of the cold air further to the east. So we're talking the eastern Midwest, Ohio, West Virginia. You can see the edge of it kind of in this area here. And the Canadian model pushing the edge further west. So what does the European model do? We'll just take a quick look at that real quick. We'll take a look at the 850 temperature, run that up to the 30th. And you can see the core of that air right there. Looks like initially it affects mostly the eastern Midwest, and then it scours that out with a warm front. See, just like that. So European model going further east with that cold air outbreak. And then the one after that on the second and third, that also stays pretty far to the east. So European model going for a bit of a warm-up around the second or third here. You can see that westerly flow setting in. I'm not happy about that. We've had too much of this mess. Okay, guys, I think that's about all I got for right now. I'll just put a frame up here for our closing segment and take a look at the chat here. Alrighty. What's my thoughts about using CAMs, convective allowing models? Yeah, I like those models a lot when we get into the 1 to 2 day forecast range. I deal pretty much here with 10-day forecasts. And my channel kind of reviews just the fundamentals. I'm just basically trying to show you how to use the charts. So the traditional models work pretty well for that. But when we do have severe weather setting in, then we're definitely going to look at those models. And I've mentioned I like the NISL WRF, the ARW version. That thing seems to nail an unusual amount of convective situations, and I'm keeping an eye on that. And of course the HRR is a good one here. And I should mention that the Canadians also have their own mesoscale models. We can pull that up on Pivotal Weather here. And RDPS, I think that's a mesoscale model. I'm not 100% sure, but I need to look that up and see what the deal is with that. I haven't used very much of that Canadian model, that RDPS. However, here you can see the convective allowing models, also what we call the mesoscale models. And there's that WRF ARW here, right here from NISL. But that kind of only runs maybe once a day. That's the problem with that. And then here we've got the HRR. So we're going to use this when we get into severe weather season. So that'll be something we're going to take a look at in the months ahead. Should be fun there. Okay, I think that's it for me. I'm going to take a break here and get dinner. Hope you all had fun, and if you have any suggestions or anything like that, let me know. Please, of course, comment, like, and subscribe. That's always appreciated. Trying to grow the channel, of course. And have a good night, everybody. We'll see you tomorrow.